Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, let's localize and landing. So right now I'm in the cockpit of the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, the displays and the function of the Boeing 787-900Z aircraft. I'm going to start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in tens, hundreds and thousands feet per minute, of the steepness of the trigonometric angle in degrees you can climb the descent. We have also the altitude indicator with the pitch ladder in degrees, the bank angle in degrees, and the artificial horizon. We have the ILS localizer, the horizontal localizer, and the vertical glide slope, so the aircraft can receive the radio frequencies transmitted from the threshold of the runway we use for takeoff and for landing. We have the runway 14 in Zurich International Airport, the Lszh in Switzerland, so we can use the onboard frequency receivers of the antennas for the horizontal localizer and the vertical glide slope, so we can align with the runway magnetic north pole heading of 136 degrees. We have also the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and zero with the autopilot and the autothrottle, lateral and vertical navigation mode. We have also the HSI, the horizontal situation indicator with the magnetic heading and track. You can see also the decorated display of the flight plan, so we're gonna create a flight plan or a flight path or a route for this aircraft to fly during this flight. I will input all the data of the aircraft for this flight and include the empty weight plus the passage plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing in the center tank also. So we'll make the calculations and we will have the flight plan displayed in the navigation display also. So we have the navigation display. You can see the horizontal and vertical profile of the aircraft as it flies. We have the terrain and weather reflections from the weather radar. You can see the red, green and yellow indications of the radar ground and the terrain map. Also for the elevation of the terrain. Also you can see with blue the lakes, rivers and the sea. We have the magnetic north pole and the geographic north pole and magnetic variation depending where we are in the world. In the terrain map you can see the airports where they are located. So we have our own airport right now, the Zurich International Airport, the Lszh in Switzerland. We have the other airports around us. The range, we have also the work stations, ADFs and DBs, the waypoints which are horizontal vertical navigation fixes the aircraft can fly through. So you will see we're gonna select some waypoints during this flight, so you're gonna see them displayed over here in the navigation display. So we have the flight management computer over here. I will select the waypoints, create the flight plan as you're gonna see later, and we're gonna have it displayed over here in the navigation display. Also the horizontal and vertical profile of the aircraft as we're gonna be flying. So you will see how far above the ground we're gonna be as we're gonna be flying. So we have here also other things you can see here. We have the other aircraft that fly around us. You can see them displayed using the transponder, the DSP and DC transmitter receiver transmits our frequency to other aircraft and the air traffic control, and receives from other aircraft and can display the other aircraft can calculate using the radio frequencies how far the other aircraft are located, the distance from our aircraft, the altitude difference in hundreds and thousands of feet from our aircraft, also whether they climb or descend with respect to our aircraft. It can also calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning using the TICA system, the Traffic Collision Advisory System, if we are in the air or in the ground. So you can see the diamond shape of other aircraft when we have it on the movement. So we have also other things we're gonna see. I'm gonna show you also the engines indications. Over here you can see the N1, the low speed starters have low pressure compressor, turbine with the turbofan with the edging, exhaust gas temperature per engine, and 2, which is the high speed starters have high pressure compressor and turbine with the turbofan with the edging, fuel flow per engine per 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. Also we have the outflow valves as we climb descent, cabin altitude, rate of climb descent, differential pressure between inside and outside, and the landing altitude. We have also here you can see the primary flight display. You can see the airspeed tape, the airspeed indicated, the airspeed selected from the autopilot flight director system panel, barometric altitude above the sea level, the target altitude 10,000 feet, and the vertical rate of climb and descent of the aircraft 10,000 feet per minute. You will see when we're gonna be flying, this needle will move up when we climb and move down when we descend. We have also the pitch ladder in degrees over here. You can see 2.5, 5.5, 10, 12.5, 15, 17.5, 20 for pitch up or pitch down, climb or descent. Also the bank roll of the aircraft and the flight mode annunciator with the autopilot and the auto throttle. Later vertical navigation modes. You can see also the HSI here, the ADFs receivers. You can see the radio altitude above the ground level right now. Also we have the autopilot flight director system panel, the airspeed selected here, the heading selected, the vertical rate of climb descent selected, and the altitude over here selected. So you will see the same values over here displayed in the primary flight display in either side. So these are the selected value with the purple or magenta color. We have 200 knots airspeed, 360 degrees, heading at 10,000 feet altitude selected, like in the autopilot flight director system panel. So you can see also the barometric pressure of the outside atmosphere, 39.92 inches of mercury. For the barometric altitude over here, the radio altitude minimum, so you can set the barometric altitude over here. For the barometric pressure, the inches of mercury hectopascal, bar set, and the minimum radio or barometric, the plan, the range of the map, weather radar over here, as you can see, weather radar, traffic, and terrain on the display. So we have accept, cancel, or reject some warnings and some messages. So we can see here other things we can see here. So we can have also so you can see the systems in the display. We're gonna have them later. CDU info, checklist, communication, navigation display, engine right now. So we have the engine displayed, indications here for the right side. So you're gonna see also the flight management computer. I will create the flight plan over here. So I will use this flight management computer to input all the data of the aircraft for this flight. So you see the thrust levers. I move the thrust levers here forward enough. I can move, I can change the thrust produced by the engines, by the jet engines, to move the aircraft forward. So you can see here the engines moving forward enough, and you see the indications also change. We have also the gross weight of the aircraft for takeoff, 358.5 thousand pounds, the total fuel on board, the fuel temperature right now, the saturated air temperature, the flaps, stabilizer trim and rudder trim, Landing gear is down right now. So you can see here also, you can see the flight controls I'm gonna use for flying the aircraft. You will see how I'm using the side stick here for climb or for descent, for making turns to the left and to the right as we fly. You will see later. So we can climb, you can descend, make turns to the right, make turns to the left. Also rudder pedals over here. So we have the rudder pedals. You can see the rudder is moving here, left and right, right or left, like this. So this is the rudder pedal or yawing axis over here. We have the elevator over here for climb descent, or the side stick in the Airbus for climb descent. So in the Boeing is the yaw. We move up the pitch axis, climb or descent. So we have the pitch axis for climb descent. Over here you can see the elevator moving up or down as we fly. Change the direction of the aircraft. So we have also ailerons and spoilers here, making left and right turns like this in the flight. So this is the control wheel over here for making left and right turns, or the side stick left and right in the Airbus aircraft. Also in the Airbus you have the rudder pedals. So in the rudder pedals we have also the tiller, which we use for the forward nose wheel steering. You can see the forward nose wheel over here. So we can use also with the rudder pedals and the rudder and the nose wheel steering, the tiller in the ground. So we can deflect 76 degrees left to right direction with the tiller, and it decreases as you advance the airspeed, like 45 knots decreases to 7 degrees right or left deflection of the nose wheel. Then you have the rudder, aerodynamically effective, about 45 knots you have the rudder, aerodynamically effective for making yawing turns. So you will see also the yawing turns. After 45 knots until 70 knots decreases to 0 degrees deflections. Then you have only the rudder, aerodynamically effective for making turns, or in the ground or in the air. So you have all the flight controls like this. So I'll talk to you about the Newton's physics, aeronautical and aerospace engineering, the Bernoulli theory of fluids, and aerodynamics. I will explain you the principles we need for flying the aircraft, all flight controls and flight dynamics. So you will see how I will explain all the equations we need for the air transport pilot license also, and the commercial pilot license. So you can see here we have the outside view of the aircraft. You can see the aircraft wings. They hold the weight of the aircraft as the aircraft flies. We have the thrust vectors from the engines, the propulsion from the jet engines, the jet blast. Over here you can see from the back nozzles, from the nozzles of the exhaust of the jet engines. So we have also the front is the front fan, the compressors and low pressure compressor and high pressure compressor and turbines. So this is the aircraft. We have also, as you can see, the minimum aerodynamic chord position in the wings is 23% of the Mach, where the maximum aerodynamic lift occurs in the forward wings as the aircraft flies. Is the position where the center of pressure also is located forward or aft as we fly. The center of gravity also over here. Also in the minimum aerodynamic chord position, 23% of the Mach, the airflow becomes detached as we fly if we reach the angle of attack for a given angle of attack, or for an airspeed that is changing in flight. It can be higher or less. So So we can see also that you have to avoid the stall of the airflow of the wings. So you have to monitor over here in the primary flight display all the time. You can see the airspeed indicator here, as I told you, in the altitude. So in the airspeed you will see the yellow and red indication down here. You have to keep your airspeed and your angle of attack below the stall speed as you fly all the time. So you won't make the aircraft stall. So you can see also here we have, as I told you, the aerodynamic position, the center of gravity, pretty much here. The load from the wings, we have the fuel tanks here and here in the center tank. So we have the center of gravity, which is the yaw axis. Over here we can see the rudder movement through, also the nose wheel through the center of gravity for making left and right turns, aerodynamic turns over here. So we have also the lateral axis from wingtip to wingtip is the pitch axis. We use the elevator over here for climb or for descent, as you can see the aircraft. So the elevator is the pitch axis. You can climb and you can descend the aircraft like this. So you see the pitch axis now for climb and descent. The rudder pedals, the yawing axis. So you have climb, descent, the elevator, and you have the longitudinal axis over here, which is from nose to tail, transversal through the center of gravity. The other axis is the roll axis. So the roll axis, you make left and right turns like this, using the ailerons, the spoilers, and the flaperons on the left and right wing like this. So this is the roll axis, left and right, using the control wheel in the Boeing aircraft, or the side stick. You use the side stick also for the elevator in the Airbus and the yoke in the Boeing. So it's no difference, it's the same flight controls you control using the control wheel or the side stick, also the elevator, the yoke in the Boeing, or the side stick here, as you can see. So we have the side stick control on the movement. So we have also here, as you can see, the horizontal trim stabilizer. In the horizontal tail you can trim the horizontal tail of the aircraft as you fly. So you use this trim switch over here to trim the horizontal elevator, trim up or trim down as you fly. You need to do that to relieve the air pressure. You can see stabilizer trim over here. So this way, elevator trim over here. Elevator trim, left click down, right click up. So this way you trim, you pitch the nose up. As you fly this way, you pitch the nose down. So you trim the elevator up, you pitch the nose up, you trim the elevator down, you pitch the nose down. So you do that like this. As you can see, this is pitch up like this is pitch down. You can see also the flap speed over here displayed in the panel. You have also the head-up declarer, some other switch over here, and the autopilot disconnect here. Autopilot disconnect and head-up declarer. So this is the elevator we need. So this trims the elevator surface over here as you fly the elevator for climb descent, and you can also trim the elevator using the switch here. You can see the elevator trim switch over here, and I have it. We have also, this is a fly-by-wire aircraft, so this is the manual trim channel. It has a flight control computers, it's a fly-by-wire aircraft. It has also the automatic trim, the auto trim function of the Boeing 787. So when you use the autopilot flight director system panel, the auto throttle, the flight management computer with the L nav and the V nav modes, you will see later. We have the auto trim function that the aircraft can trim itself using its flight control computers in flight. So you don't need to trim it, maybe a little bit. So you have also this function. If you have over here failure of the hydraulics system, you can see the hydraulic pumps over here in the overhead panel, the demand and primary, the engine driving and the electric driving. Over here left and right engine and electric C1 and C2. So you're gonna have a failure of the automatic trim over here. You can also see the flight control computers over here, primary flight control computers over here in the auto position. We have also other things here, data computer and flight control surfaces. So you see primary flight control computers control the flight controls of the aircraft, like in the Airbus. We have the normal, alternate and direct flow of flying the aircraft. So if you have a failure of the hydraulics, that affects over here, as you can see, we have the stabilizer discarded switch, stabilizer cutoff switch. So you have to open this guarded switch from normal to cutoff. If you have a failure, it's for all Boeing 737, 747, 757, 767, and Boeing 777 and Boeing 787. You open from normal to cut off these two switches. Then you lose the normal. You can see L2 is the left and the R2 is the right horizontal stabilizer trim. So this is the auto trim channel. You disconnect over here from horizontal trim. You have the manual after that over here, the manual trim. So you can trim the horizontal tail like this all the time. And also you have the alternate channel, the alternate channel over here, pitch trim. So we have also the alternate. You can trim the nose up, pitch the nose up when you trim the elevator up, or trim the nose down when you trim the elevator down. So like this is pitch up the nose in flight, and this is pitch down effect. So we have also other things. You can see here the parking brakes over here. Nose up, Lszh, SAT, weather radar, transporter, SAT, high frequency VHF, cabin. So this is the radio frequency receivers, and also weather radar, transporter, high frequency receivers. So we have all this for the flight controls. As I told you, use the manual trim over here, and you can see the horizontal tail will move up and down the whole elevator or stabilizer as we fly for trimming. So this is a general explanation. Also we have here, as you can see, that I was telling you about the aerodynamics. You can see the wings of the aircraft, you can see the top surface and the lower surface, complete the explanation. So you can see the bottom surface of the wings is more flat, and we have the flaps extended. Also the aircraft will be having a positive angle of attack in flight. So we have lower airspeed of the airflow using the Bernoulli theory of fluids. So we have higher pressure, which pressurizes the aircraft weight and wings up into the air as we fly. We have higher pressure below the wings. Also you can see the top surface of the wings is more curved, so as we fly we're gonna have higher airflow, higher speed of airflow above the wings, which creates lower pressure, which sucks the aircraft weight and wings up into the air. So this is the explanation for flying, the aerodynamics. Also the flight controls explanation here, as you can see. So I'll show you one more thing about the flight controls, a couple more things. Two more things about the flight controls we need to know. So I'll show you one more view of the flight controls, also the flaps and slot. So we can control the elevator with the side stick, the load stick, the stream. 3G for climate descent. Also make bank roads left and right using the ailerons, the spoilers, and the flaperons of the left and the right wing. Also the rudder, using the rudder pedals and the nose wheel, steering the forward nose wheel, and the toe brakes we have in the rudder pedals. Also we have the horizontal trim stabilizer, the thrust levers. I have them all set up here in the side stick, as you can see, for flying the aircraft. So we have full flight controls over here. I have also the flaps and the slots and the speed brakes, horizontal trim stabilizer, thrust levers. So I'm gonna show you one more view of flying of the flight controls of the aircraft. Then I will show you the flight management computer uh, and how to set up the flight plan of this aircraft for this flight. So you can see here we have um, the side stick that I'm using. So you can see very the screen better view over here. So you can see also this view we have for using the flight controls of the aircraft. So you can climb, you can descend, make turns to the left, to the right. So you climb and you descend, you make turns to the left, turns to the right, like this. So hope you like. Horizontal trim stabilizer also. Thrust levers over here. You can move the thrust levers over here forward and off, like this. So this is the full flight controls over here, the thrust levers also. So you can see the thrust increase or decrease over here, the thrust lever position, and the side stick also, and I'm using for flying the aircraft. So hope you like it. You can leave neutral also in flight. So climb, descent, make turns to the right, make turns over here to the left. Horizontal trim stabilizer also. So we have full flight controls like this. So this is the side stick. Which is identical to the Airbus. You can see the captain and the first officer side move together in flight. They are interconnected. The yoke, also the control wheel and the rudder pedals, they move together. They're not moving independently from each other. So this interconnected flight controls and the rudder pedals. They're not like in the Airbus. You have the side stick priority. You can take either left or right side. Use the side stick priority button. Also the side stick deflection right now is proportional to the yoke deflection. Also the flight controls from outside. You can see the rudder again. Rudder pedals, elevator for climb descent. Over here ailerons and spoilers. So you climb like this, descent. make turns to the left and to the right. So this is all the flight controls we need to know right now. So I'm gonna show you. Also you see the inside again, flight controls. I'm gonna show you the flight management computer. You can see also we have here the flaps and the speed brakes. So the flaps position here as we move. If I move the thrust levers forward, you can see I can retract like this, or I can extend like this. You can see the position of the flaps like 17, 18, 20, 25, 30 degrees, or retract again. This is the flaps position. So you can see the flaps with our position right now fully extended. Over here you can retract, as I told you. You can see flaps retract. You can see the flaps now are retract in both left and right wing. Also, if we extend them again, you will see the flaps extend like this, fully extended. You can see in the display over here, if they are in transition now, they extend. So they're fully extended like in a couple of minutes. You can see also the speed brakes now retract, extend. Would act also as flight spoilers inside. So it's both flight spoilers and also speed brakes. So we have the speed brakes here. We have the thrust reverser over here, the thrust control, as I told you, thrust levers, auto throttle, disconnect over here, takeoff ground. So you'll see later. We have the fuel control for the left and the right engine. The fire extinguishers for the left and the right engine, pull out and switch. The transporter over here. So this is the radio management panel, as I told you. Radar trim over here. So this is most of the panels over here. Also the overhead, you'll see other things like the electric, hydraulic. So we have now the flight management computer. You can see I'm having the mouse pad here to control the inputs I'm using for the flight management computer over here. So I have also my mouse here, as you can see, to control all functions here of the aircraft. So instead of using that mouse pad over here, so you can see now I can use the index here. I can move around the flight management computer screen using the mouse pad. So you can select identity over here, index, also other functions you will see in a couple of minutes: position, performance, takeoff, approach, navigation, data, load, and traffic control plan. Also here the keyboard, some functions we have. Also we can use the mouse pad for this. You can see the touch screen here for making selections, also the systems, the navigation display. So you will see all the functions now of the flight management computer. I will input all the data of this aircraft for this flight. Then includes the empty weight plus the passenger plus the cargo plus the fuel on board, with the fuel stored in the left and the right wing and the center tank. So we have 30% in the left and the right wing tank, 10% in the center tank. The flight management computer is going to calculate the loads also from the fuel and the passengers and the cargo. It will give us the minimum aerodynamic chord position of the aircraft for takeoff, the Mach 23%, and also the center of gravity position for this, and the minimum and the horizontal stabilizer trim position for takeoff, 4.25 degrees, or the elevator trim from takeoff, climb, cruises, and approach and landing. Also the center of gravity as we burn fuel is lifted, so it's recalculated every second from the flight management computer in flight. Controls gives commands, field functions, main functions of the aircraft, and the flight control computers, the autothrottle and the autopilot flight director system panel. So you will see also we use 15 degrees of flaps for takeoff. We're gonna select the runway. We have the Zurich International Airport and runway 14 for takeoff and for landing. So we're gonna select this airport and this runway. The flight management computer is gonna calculate the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature, and also the runway conditions. If it is size driver, it will give us the takeoff speeds V1, V rotate, and V2. So we're gonna take off at about 140 knots, 230, 240, maybe more, 270 kilometers an hour. So we're gonna have 15 degrees of flaps and 9 degrees of pitch attitude for rotation. So you're gonna see we're gonna use the side stick or yoke for pitch attitude in takeoff. We're gonna have also the seeds, the southern instrument departure waypoints and fixes that will horizontal vertical navigation fixes and altitude and airspeed constraint for the initial climb and departure of the aircraft. We're gonna climb to an altitude like 25, 26, 27, 30, 29, 30,000 feet above the sea level. We're gonna cruise and cross through some waypoints over there and make some turns in flight. So we're gonna have also the top of descent. We will initiate the descent from the cruise level to about 7 or 6,000 feet above the sea level, closer to the elevation of the airport. For approach and landing, we're gonna have the stars. The stars are the southern terminal arrival waypoints and fixes that will include horizontal vertical navigation fixes and altitude and airspeed constraints for the terminal approach and landing of the aircraft. Into the runway, we're gonna align with the horizontal and vertical localizer, the horizontal localizer and vertical glide slope of the Lszh localizer of the instrument landing system of the airport that transmits radio frequencies from the runway threshold, and as I told you, they are received from the onboard antennas of the aircraft and can calculate using the radio frequency difference of the horizontal localizer, the vertical glide slope. As we approach for landing, for alignment with the horizontal localizer, we're gonna have 136 degrees for the runway 14 of Zurich International Airport, Lszh in Switzerland. So we're gonna have approach and landing with the Lszh localizer manual. We're gonna use about 60-70% of thrust for approach and landing, about 25-30 degrees of flap, 160-170 knots, offer speed like 300 kilometers an hour or more. And also we're gonna have the landing gear extend, and you're gonna see how we're gonna do that using the flight management computer. We're gonna have a complete route of flight path or flight plan. So we can use the flight plan. Also is interconnected, as you can see here later, with the LNAV, with the VNAV function of the autopilot flight director system panel. It takes the inputs from the flight management computer over here. So gonna use this control quadrant over here. So you can see we have the mouse pad here that I told you. The mouse pad is here, the keyboard, and the functions of the CPU, the control display unit. So we have identity here, position, performance. You can see the purple color, the box that selects either mode, takeoff, approach, annunciate status, navigation, flight plan, load, air traffic control, load, flight plan, save, flight plan. So we're gonna start identity, Boeing 787-900 engines, GNX, Z engines. So we have position here, the reference airport we can use for alignment with the inertial reference system of the air data computers, with the laser gyroscopes. We have the performance here. So we have 0 fuel weight plus fuel on board gross weight. We're gonna use the cruise altitude, cost index, fuel freezing temperature, cruise center of gravity, and the reserves fuel for this flight. So we're gonna start with the route first. We're gonna select the departure and arrival airport and runway, Lszh origin over here. Displayed with blue is not yet active, as you can see. And we clear over here and select the runway 14 for takeoff. So we're gonna have the route. We're gonna set also departure and arrival over here. So we have the departures. We can select either runway 10, 14, 16, 28, 32 over here for takeoff, runways for takeoff. The right side and the left side is the seeds, the other instrument departure. So we select runway 14 and the seeds Zui to Alpha. So we have the Lszh departures, as you can see. So this is gonna set the flight plan, initial waypoints. Also we can select now the approach. So we have approaches VOM 1628 34 ILS 14 over here, ILS 16, ILS 28, ILS 34, GLS 14 localizer 28, localizer 34. So we select also we have the stars, other terminal arrival waypoints and fixes. So we select here ILS 14 trans Amity this waypoint and trans Negria over here. So this is the starter terminal arrival waypoints and fixes for the terminal approach and landing, the long final, the short final. So we have the route with blue over here, route 1 legs. The heading 136 degrees for takeoff, 2 nautical miles, first waypoint, second, third, fourth, Zui, 6 nautical miles after many. We have a discontinuity here. We climb to the Nigra motive, then it's descent, approach and landing over here, the stars for approach and landing and the runway. So we need to initialize first. Zero fuel weight 322.7 thousand pounds plus the fuel on board, 33.9 thousand pounds, gross weight 356.5, reserves 5%, the cruising altitude 25,300 over here. You can see 25,300 feet, and the cost index 100%. Fuel freezing temperature minus 37 degrees. Center of gravity cruise 28%. So we need to recirculate the fuel in flight so it won't freeze. Over here you can see fuel freezing temperature. So we have also the legs now. We can press the exit button here, the green. It will give us the white. The route is active, 136 degrees heading, the first waypoint, 2 nautical miles, 250 knots, airspeed and 1900 the altitude above sea level, TRO 1 nautical mile. We make a left turn, 3 nautical miles, heading 014, 5 nautical miles, Zui 052 heading 6 nautical miles, 6000 alpha. Then we climb to the Nigria heading 071, 26 nautical miles from Zui, 301 knots, flight level 22,200. Then we make a right turn here, motive 12 nautical miles from Negria, 320 knots, with descent to the elevation of the airport 11,800 feet, Amity 258 heading 6 nautical miles, 190, 10,400, 276 degrees, Zui 9 nautical miles away from Amity, 180, 7,000 alpha, Z8701, 290 degrees heading 6 nautical miles, 180, 6,000 alpha, 6 nautical miles from Zui TRA, 290, 10 nautical miles, 185,000 alpha, C1 CI14, 6 nautical miles from TRA, 184,000 alpha. Then we make a left turn, the heading of the runway 5 nautical miles, 170, the magnetic north pole, 136 degrees, 174,000, runway 14 approach and landing 8 nautical miles, 140 knots, 1,400 feet. So we use the flaps for approach and landing, 15 degrees, center of gravity 23%, 4.85 degrees, and the V1 we rotate, and V2 128, 130 we rotate, and V2 140 gross weight for this runway 14. So this is the complete flight plan or flight path route. We have also other functions, alternate, VNAV, progress. Over here you can select using this touch screen over here, flight management computer. Hold, we can select a waypoint and hold in flight. Fix, we can set a fixed ring. Over here navigation radio, you can tune the ILS localizer or the words in flight for instance. So we have again the virtual cockpit here. We can see a few more things, so we need to set up everything for flight. So you can see we have the display of the flight plan here, the navigation display, the terrain in front of you, the runways we're gonna use from the GPS. You can see the runway. We have in the right side the taxiway, the left side runway. You can see the terrain in front of us as we're gonna be flying. The climb over here, this line. So we have the waypoints here inserted. So the taxiway in front of us and the runway to the left side is the same. Also the terrain as the one displayed from the GPS display with the terrain and weather reflections. You can see the terrain, the waypoints. So if we look further away, you will see like small mountains in front of you. This is how we need to clutch them. We can see with yellow, green and red if it is higher than us. The distance in nautical miles right now is 10 nautical miles away, the maximum. Displayed also the horizontal. So you see these mountains over here displayed in the navigation display over here. We have also the center display. You can see the 360 degrees. The flight plan we have created, the waypoints we have to cross through here as we're gonna be flying. As you can see here in flight. So we can change also other modes here. You can see more airports, the waypoints again, the flight plan we have created from takeoff from this runway, climb, cruise, descent, approach and landing one by one. Also map centering over here, the terrain elevation for this distance. Some airports. So you can see better the waypoints again, one by one, with their name over here. So we have also, as you can see, the map again, the range. Further away you will see more airports. So you can see here we have the Germany here, the France and the Switzerland down here in this area. In the terrain map you can see the names of the airports. So if you look closer, also the indications from the engines a couple more minutes before going to takeoff. The autopilot flight director system panel, we're gonna set autopilot engage, autopilot disengage over here. Auto throttle left and right over here. Airspeed, you can set the airspeed as I told you, whatever you need to be for takeoff. The LNAV and VNAV over here. So you can turn off the flight director. You cannot rearm the modes like this. You disarm the modes. So both are armed like this. LNAV, VNAV, flight level change, so the throttle climb continues. Bank angle automatic and heading select. We're gonna select the 136 degrees of the runway we're gonna use for takeoff and for landing. Over here, vertical speed, flight path angle over here. So you can set it, you can descend like this. You see the minus. So this is the autopilot panel, very important. Use 3,500 like this. The altitude 35,000 like this, and 300 feet. World localizer approach for autoland, also other functions. So I'm gonna show you now. I'm gonna set the electrical. You can see the IDG here, the APU, the auxiliary power unit, the battery, left and right engine drive and IDG, 120 200 volts, 400 Hz frequency. Primary flight control computers. So gonna make an engine start demonstration. Air data computer, flight control surfaces over here. Town power, FD door, passenger oxygen over here. Window heat, ram air turbine, and primary demand, hydraulic engine driving. You can see we turn off, it displays the fault, so we need to reset back to the on, then to the auto position. We have the electric also, So this is also, you can see the lighting and the windshield wipers of the aircraft. We have here wing and engine on the ice. Over here we have also over here the recorders, the cargo and the APU fire, electronic engine control for the engines, left and right, normal and alternate mode, and the auto start. Gonna make an auto start in a couple of minutes. We have the fuel jettison, we dump some fuel and select the nozzles to lose some weight in flight. So we have the left and right wing and the center tank, fuel booster pumps, the crossfeed valve. We can balance the fuel between the left and the right wing, or feed either engine with other pump like the tank. Fuel booster pumps here on and off, valves off. We have also the pressurizer from the engines from the APU. We need for cabin pressurization, oxygen regulation, weekend engine RDIs over here, and air conditioning, ventilation, and hydraulic fluid tanks pressurization. So we have the pressurization in the manual mode. We climb or descend. Also in the automatic, we don't need to do anything. So you'll see now how I'm gonna make an engine start demonstration. Turn on some lights also. So we need a couple of minutes more for going into flight. So you can see here the systems that I showed you in the overhead panel. You can see we have the hydraulics, the APU is running, oxygen and liquid cooling, the electrics over here, left and right controllers and driving, the APU is running. So we have 100 to 200 volts for 100 Hz frequency, the battery voltage and amperage and the load cell. So we have the hydraulics, where the hydraulic fluid goes, left and right engine driving, electric C1 and C2, 5100 psi, and the quantity of hydraulic fluid. The fuel, left and right wing, fuel tank, center tank, 11,000, 11,000, 11,000, 33,000, 300. The crossfeed valve is off, but we turn it on. You can feed either engine without the power the tank, and also balance the fuel between the left and right wing tanks. So we have low high pressure fuel valves. Also we have the recirculation of fuel from the wing tanks and the center tank, because you see the minimum fuel temperature from the FAREX is automatically controlled. It's gonna freeze in flight. So we have also the APU sphere from left wing using this motor. You see the temperature, the air conditioning, doors are closed, the cabin can be pressurized, the gear, pressure of the tires and temperature of the brakes, flight controls over here. So you can move the flight controls. Over here you'll see the movement as we fly of all the wing surfaces, flight controls, deflection, the tail, horizontal trim stabilizer, airfield display, maintenance. Over here system, circuit breakers again. So we go for the checklist also, checklist last thing. Before start, after takeoff, descent, approach, landing. We have many modes to select over here. So we'll go again, navigation display. We turn off both engines, as you can see over here. Both engines in the off position. Fuel control in the off, so you'll see. I'm gonna restart the engines. They're going off right now. So we have a couple more minutes for going into takeoff. So we need to come over here and turn the auto start on. So this is gonna give us now pressurizer from the APU over here into the engines compressors to compress to supply pressurizer to the engine starters. So you can see we have only pressurizer to the engines right now. So you can let the fuel flow above 20%. Over here fuel control, both left and right on. So we have the auto start is kicking in. So we start the engines, both of them. So you can see it's increasing in pressure and fuel and temperature right now. So temperature also increases. So here we are above 60%, you're gonna see the engines are running with green letters. So here we are running. So we can go for takeoff, flaps for takeoff over here. Parking brakes off, advance the thrust levers. We take the clearance from the air traffic control. So this is the runway we're gonna use for takeoff and for landing. So we use the tiller for nose steering. The runway is open for us right now, as you can see. So we use the tiller. We align with the center line over here. And we go in for takeoff. So we have the thrust to full takeoff power, like this. And align with the center line. So we press the yoke down until 100 knots. Rudder pedal, left rudder pedal. So we have 100 knots, 120, 130. So we have V1, we rotate. Over here picks up slightly on the aircraft, as you can see, like 9 degrees. Keep climbing. So this is the positive rate of climb right now. So the landing gear goes up. Keep climbing. And we have 15 more minutes for this flight, for this video. So you can see here the airspeed is 180 knots, 179. The wind direction and speed also we are 2000 feet above the ground, 2100, 2200, 2300, 400. So 4000 feet above the sea. It's a difference, 5000 feet per minute. The needle rate of climb, the terrain, red, yellow and green, the heading, wind direction again, the pitch altitude and the stall speed here, yellow and green, yellow and red. You have to avoid the stall speed. You can see also how far above the ground we are flying right now. If we also look around over here, you can see we look closer. You can see we are just like 3,000 or 4,000 feet above the ground right now. You can see the green below us in the vertical display. We are 6,000 feet above the sea level, 7,000. So we keep climbing. So we need to make the turn now, as you can see. The outside view of the Switzerland here, the lakes, the Swiss Alps, and the airport over here. So we need to make a turn. We're gonna start on the turn to follow the flight plan here. So very easy to make the turn. And we need like 15 more minutes to go for landing, maybe less. So this is a beautiful view over here of the aircraft, of the Boeing 787 as we climb. This is a nice view, the Swiss Alps. Gonna be flying closer to the Germany also, as you can see, and the France also. So we follow the flight plan, and we have 12 more minutes to come back for landing over here, 13,000. You can see we need to cross through these waypoints here. The engines also indication. We have maximum takeoff power right now. So you can see we can leave the flight controls off. There's no problem. The aircraft keeps flying the way it should be. Only the aircraft can do that actually. No other flying machine can leave the flight controls. It will keep flying if it is trained properly. So you can see we leave the flight controls off without the autopilot, no problem. The aircraft keeps flying the way it should be without any flight controls. Input only a little bit, small corrections. So we have 15,000 over here. Maybe increase the airspeed as we fly. So we keep climbing. You can see all flight controls, the cockpit also here after takeoff. Also the head-up display over here, what it displays. Autopilot over here. We have on DL nav. We keep climbing. You can see the trend line as we climb, the green, the flight management computer. So we have a beautiful view of the cockpit of the jet aircraft of the Boeing 787. We need to make a small turn now. Over here, more right turn. There's no problem. So we have the Zui here, the first waypoint we have here. Zui is 2 nautical miles, 1.9 from us. You can see displayed the map. The wind 25 knots right now, and the vector of the wind to keep climbing. And now we're gonna make a small right turn over here to follow the flight plan. As you can see, I'm gonna fly over the lake over here. So we align with the flight plan. Over here we have the other waypoint, the Negria right now. 34 nautical miles, also displayed in the map here. The airspeed again, we need to pay attention. The indications. So we have over here, you can see a beautiful view. The galaxy, the France, the Germany, my homeland, the Bayern Munich, the Germany in front of you, the lakes over here, the Swiss Alps, the Italy behind us. So going back to the airport, we're gonna start the turn here for going back to the airport. So we turn over here. Keep climbing. You can see we have the waypoints here, the flight plan. We need to follow as we make the turn. So we leave the Germany here. We have also the chemtrails now created. The vapors from the frozen vapors from the engines. It's crystallized over here from the frost. The lake over here, beautiful lake, and the Germany, Bayern Munich, and the Switzerland, Swiss Alps. So we're flying over here, like as you can see. "33,000 feet. We make a small more turn over here. And we're gonna start the descent in a couple of minutes. So we retract the flaps. Need to increase the airspeed of the aircraft. Keep flying manually. So gonna increase the airspeed right now of the aircraft, as you can see. So here we are, 24,000 feet above. You can see the vapors over here, and we have 6 more minutes for coming back for landing. So we are overflying here. Beautiful view, the Germany, the lakes also, and now the France over here, as you can see, and now the galaxy. So this is the frozen vapors from the aircraft. So we start the descent now over here. Idle thrust and speed brakes. So we start the descent now for going back to the airport, as you can see. So we're going back to the airport, descending right now. We need to cross through some waypoints again. Come closer for approach and landing over here. As you can see, cross all the waypoints, the approach for the airport. And we have 5 more minutes. So we have the runways over here. You can see the runways as we approaching for landing. So idle thrust now. And we have 4 more minutes. So we need to increase the rate of descent over here. There we are approaching for landing. Also start the turn in a couple of seconds. So this is over here the turn, as you can see, for approach and landing. And we have 3 more minutes left. Over here we need to align with the runway as we are descending. Also decrease the airspeed a little bit. So we're gonna cross through the clouds here, as you can see. Keep descending. So we are almost aligned with the runway. We need 2 more minutes to approach for landing. As you can see. So we use manual flight controls over here. Overfly the river. Flaps also. All down flaps. So we need to align with the runway shading. You can see also the outside view. I'm gonna have a nicer view for landing over here. As you can see, runway shading, and 2 more minutes for approach and landing here. So you can see the runway we have to follow over here. Also the Lszh localizer, the instrument landing system, we follow for approach and landing. Thrust manual, and we have a few more seconds for approach over here and landing. As you can see, 1 more minute. So we have some side wind, some wind gust. We need to combat the wind gust and the side wind as we are approaching for landing. So wind gust and side wind makes more difficult. You lose the heading as you approach. We need to maintain the center line over here for approach and landing. So also increase the rate of descent a little bit. Increase again the rate of descent, idle thrust, and we are approaching for the flare of the aircraft over here. Flare and touchdown. So we have a very beautiful flare over here, as you can see. Very beautiful flare, touchdown. So this is very beautiful. And parking brakes over here, and idle thrust reverser over here, as you can see. Thrust reverse and idle thrust, and we're slowing down the aircraft like this, as you can see. So this is the aircraft slowed down. You can see all the landing gear here is perfectly safe.